we're going to look at the basics of simplifying here, which is the process of combining terms. Simplifying also includes things like removing unnecessary powers and roots, but that's a later video. So we can add two terms, subtract, multiply or divide, and in each case two terms are combined into one term, and that's called simplifying. Powers and roots are dealt with later. Some important conventions before we start, because otherwise we can't really get it right. If we don't write a number in front of a variable, then there's a 1. We don't write it, but it's still there. If we don't write a power to a variable, then it's a 1. Again, we don't write it, but we must use that when we deal with additions and multiplications. If we write a power, then it applies only to the variable it's attached to. 5xy squared is only a y squared. A negative applies to the variable and makes it -1, but to the power of -1 is not a negative number. The negative indicates that the x is on the bottom line in this case, not negative. And variables are numbers, and all the rules of numbers apply, such as bed mass. So we multiply before we add, and subtractions only apply to the thing that is following. In this case, only the 3x is subtracted, just as we would do it without the algebraic terms. 4 minus 3 is 1, plus 6 is 7. But that's different if we put brackets, because the brackets tell us that everything following has the subtraction applied. So that is 4 minus both the x and the 6. And these are our basic rules. Come back to these at the end. Adding. Add the numbers in front and the variable doesn't change. So we look at this. We have 6 and 3 x's. So we add them. 6 and 3 is 9, and the x does not change. We look at these two. They have x and y. We add 3 and 7 is 10, and the xy does not change. Must resist when we have powers to change the power. In this case we have 2x squareds, so we add them and it remains an x squared. If the variable is different, then we can't keep it the same, so we can't add them. Very important, we cannot add if the variable is different in any way. So x and y are not the same, we cannot add them. X squared and x are not the same, we cannot add them. That's called adding like terms. We can only add the ones that have the same variables, what is called like. So in a case like this, we can add the x's, we can add the y's. We have 10 x's and 7 y's, but we must stop there. The answer includes a plus sign. Cannot add unlike terms. And the same with the powers. We can add the x squareds, add the x's, but we cannot add them any further than that. It applies to numbers as well. We have two x terms. Note that there's a 1 in front of there, so we have 1x and 5x is 6x. The 3 is separate and has to remain separate. Numbers are not like variables. Subtracting is the opposite of addition. Subtract the numbers in front, the variable doesn't change. So we have x's, 6 of them minus 3 of them leaves us 3 of them. We have xy's, 3 minus 7 is minus 4, and there's no problem having a negative variable. X squareds again, power does not change. 8 minus 2 is 5, the x squared stays the same. You have to be very careful when you get ones like this, however. There is a 1 in front of that p. So we're not taking p away from p, we're taking 1 away from 5. 5 minus 1 is 4. The variable does not change. Don't try to subtract the p. That's 1p, and the 1 is doing the subtraction. There's only one case, a special case, when the variable disappears, and that's when you take a number away from itself. Because 4 minus 4 is 0, and notice the 0 is here, and we don't write 0x. It's not wrong, but we just don't write it, we just write 0. Rules for like also apply for subtraction. We cannot take a y away from an x. So we get a string of adding and subtracting. We separate the like terms out, and the x's are dealt with and the y's are dealt with. Note in this case that the subtraction only applies to the minus 5x, and that plus 4y is added to 3y to give us 7y. Multiplying, we multiply the numbers in front, and then we add the powers of the variables. 3 6 is 18, and we have 1x, and 1x is 2x's. 3 7s are 21, we have 1x and 1y. 3 4s are 12, and we have 1 2 3 plus 2 is 5 x's. We're not actually adding the variables, we're multiplying them, but that's because a power is an increase in multiplication. X squared is x times another x, so every time we add a power we are in fact multiplying. Dividing is the opposite. Divide the numbers and subtract the powers of the variables. So in this case 6 divided by 3 is 2. We have 2 x's and take away 1, we're left with 1. 30 divided by 4 is 7.5, we had 4, divide out to 2, we're left with 2. And that can give a negative power. 9 divided by 3 is 3, 1x, take away 2, leaves us minus 1. In this case, 30 divided by 4 is 7.5, the x has nothing taken away, and the y is taken away from no y's, so we have minus 2. A lot of people find that quite tricky, so we don't do it that way generally. We generally do it by way of fraction techniques, cancelling out the variables. So 6x squared divided by 3x is 6x squared over 3x, and then one of the x's cancels on the bottom, one of the ones on the top. It's the same as the subtraction. That gives us 2x over 1, because 6 over 3 is 2 over 1, and we don't write the over 1, we just write 2x. Anything that starts as a division ends as a division, so it stays on the bottom of the fraction. So in this case, we write it as a fraction, we cancel one of the x's from the bottom, subtract it off the top, and 6 divided by 12 is a half. The 12 is bigger than the 6, so the 2's on the bottom, and the y has started out as a division, so it remains as a division all the way through, and our answer remains like that. People usually find division hardest when you're cancelling out the whole of the top line. So in this case, we have x divided by 8x, but that is 1x divided by 8x. So when the x's are cancelled out, the 1 is still there. Very important all the way through. If you do not have a number there, there's a 1 and it stays as part of the answer. Slightly more complicated case. The x on the top cancels 1 on the bottom, and we're left with 2 over 6 is 1 over 3, and the x remains on the bottom. So these are our basic rules. Adding and subtracting. We add the numbers, subtract the numbers, and the variable must not change. Multiplication and division. We do the multiplication and division as usual, except we add the powers for multiplication and take them away for division. More complicated divisions usually are better done as a fraction.